Now let's move on to talk about carboxylic acids and carboxylic acid derivatives. So the carboxylic acids and its derivatives are all another class of compound that have the carbonyl group. They are not called carbonyl compounds because now the carbonyl carbon is attached to a different group. It may call it as a functional group as well, but the whole functional group of carboxylic acid is the carboxyl group, which is the carbon with the double bond O, and the carbonyl carbon is attached to an OH. So this is the carboxyl group. The carboxylic acids are named by using the suffix oic. So the simplest carboxylic acid is the one with only one carbon. The carbon that has the carboxylic acid group is considered part of the acid. So the simplest acid is the one with only one carbon. So this is called a methanoic acid. So methan and oic. So we replace the E of alkane with oic. So this is methanoic acid. It has a formal name as well, which is called formic acid. The second acid here, the second one is one with two carbons. So it's one, two, and according to the AUPAC system, we call this ethanoic acid because there is ethane, so it's two carbons, so eth, and then we replace the E in ethane with oic, so it's ethanoic acid. The formal name of this is acetic acid. Acetic acid is the acid we use in the vinegar. So what about the acid derivatives? So the acid derivative, they come when we replace the OH in the carboxylic group with a different group. So if we replace the OH with halide, so the OH here was halide, we end up with acid halides. For example, acid chloride, so like RC double bond OCl. So these are called acid chloride. If you replace it with another carboxylate group like this one, alkyl carboxylate group, then it's called anhydride. So anhydride is carbonyl group, then oxygen, then another carbonyl group, and you have two alkyl derivatives on both sides. These are the acid anhydride. The esters, when you replace the OH with an OR, so you replace it with with the alkoxy group. So this is called an ester. Then we have the amide when we replace the OH with an NH2. The amides can be either primary with just NH2, or if the N is substituted with other alkyl groups, it can be secondary and tertiary, and we're going to talk about that. Nitriles is another series of compounds that are considered to be derivatives of acids, although they don't have the carbonyl group. The nitrile, here we replaced the C double bond OH with a C triple bond N. And then we have the alkyl. These are called nitriles, and the nitriles can give us the acids again. So let's start with naming the different, see how can we name the different acid derivatives. So let's start off with the esters. Esters are very common in nature, and we always deal with esters, and we see a lot of solvents which are esters like ethyl acetate. So to name esters, usually we name it as alkyl carboxylate. So you look at the carboxylic acid, what is the carboxylic acid, and then you name the alkyl function as alkyl carboxylate. Let's have some examples. So let's have an example like this one. So where is the acid? So the acid here is the one that has the carbonyl group attached to an alkyl. So this is our acid derivative. It has two carbon atoms. So if we are using the ABAC system, this is ethanoic acid. If we are using the the formal name, this is acetic acid. So where the alkyl derivative is this one. So we can either take it like 1, 2, 3. So it's propyl with a methyl group on carbon number 2. So like 2 methyl propyl. ethanoate, or we can call it isobutyl. So this is also as a whole is called isobutyl. So either way is correct, but to follow the exact AUPAC naming system, you have to call it 2-methyl propyl ethanoate. To call it the formal name, it's going to be called isobutyl acetate. So we replaced the oic with 8. So now it's acetate or ethanoate, not ethanoic acid. So 2-methyl propyl ethanoate. So let's have a look at this one now. What is the acid? So the acid, this is the carbonyl group. Now this is only one carbon. This is the oxygen. So this group is called benzyl. So this is going to be called benzyl methanoate. So we call it methyl methanoate because it's only one carbon, so it's methanoic acid. If we use the formal name, which is formic acid, then it's going to be formate. So it's called benzyl formate. You can also call it phenyl methyl. So if this is the longest series or the longest chain of carbon atoms, so it's only one carbon and there is a phenyl group here, so you can also call it phenyl methyl methanoate or phenyl methyl formate. But when we name these compounds in organic chemistry, we usually call this as benzyl. So this is called benzyl. So it can be benzyl formate. So what about amides? Amides come from the replacement of an OH in carboxylic acid with NH2 or with a nitrogen with some substituent. So here these are the amides. So unlike amines, if you remember that amines are which have an H2 amines, we said it's basic. Amines are basic and they are able to form salts with acids, so you can have something like that, or NH3 plus Cl. So they can form salts with acid and they are basic because the lone pair of electron on the nitrogen of the amines are available to be taken. So they can donate these electrons. So they act as Lewis bases. This is unlike amides because the lone pair of electron in amides here are not available because they are always engaged in resonance like this. So the lone pair have much less availability compared to amines. So amides are not basic or very, very weakly basic compared to the to amines because the lone pair of electron on the nitrogen are always delocalized. They're always moving and making resonating structures with the oxygen on the other hand. When it makes the resonance, the nitrogen will have a positive charge and the oxygen will have a negative charge. Classes of amides. We have 3 classes of amides, exactly the same like amines: primary, secondary, and tertiary. So primary amides, when we have the nitrogen of the amide group with attached to 2 hydrogens. So these are primary amides. Secondary amides, when you have the carbon here has 1 alkyl group and 1 hydrogen. So this is secondary. And tertiary amides when the nitrogen has 3 attached to 3 different groups with no hydrogen at all. So these are called tertiary amides. How can we name amides? For primary amides, we drop the suffix ic or oic for oic acid from the carboxylic acid name, and then we put amide. So for example, here, where is the parent acid? This is the parent acid. Okay, so 1, 2, 3. So there are 3 carbons. So this is propanoic acid. So we drop oic, and then it's going to be propanamide. We added amide, so it's propanamide. So this is how we call it. Now we have to look at the different substituents, both on the nitrogen and also on the acid, the carbon chain of the acids. So for the nitrogen, we have 2 substituents. We have an ethyl substituent and we have a methyl one. And on the carboxylic acid carbon chain, we have a methyl group on carbon number 2. So for the substituent on the nitrogen, we have to put the letter N in front of it because we mean that the substituent are on the nitrogen of the amide group. So we call it N-ethyl, and then we have N-methyl. But again, for the carboxylic acid derivative or chain, we have a 2-methyl as well. So we have two different methyl groups, so we don't write methyl twice, but rather we just put N2-dimethyl. So we don't write methyl twice, but we just put where are these two methyls, and then we write a dimethyl. In the same way we used to name it when we give, if we have two substituents of the same type, then we just put the numbers of the carbon atom where they exist, and we then write di. So the final name will be N-ethyl N2-dimethyl propanamide. We started with ethyl because of the alpha. We have to arrange the substituent according to the alphabetical order. So we start with ethyl and then methyl. Ignore the di completely when you do the arrangement. And then the parent name will be propanamide.